This video is on graphing linear equations. We will have three methods in which we will be able to graph these linear equations. These linear equations are called linear because when you graph them, you should get a line. So that's where linear comes in. So when we look at those methods, we're looking at the XY chart using your intercepts and then graphing using your slopes. So looking at the first method, using the XY chart, let's say if we want to graph at y equal to 2x plus 1. First thing you would do is you would choose some x values to plug in. You can use 2 values, 3 values, 4 values, it doesn't matter. It doesn't matter which values you choose either. Just remember that whatever you choose, you have to graph. So I decided to use -1, 0, and 1. So plug in for x. I'm plugging in -1 for x. That's 2 times -1, which is -2. -2 plus 1 is -1. So it just so happens in this case when x is -1, y is also -1. Of course, that will not always occur. Plug in 0. 2 times 0 is 0. 0 plus 1 is 1. So when x is 0, y is 1. And then plug in +1. 2 times 1 is 2. 2 plus 1 is 3. So when x is 1, y is 3. So we have 3 points, -1, -1, 0, 1, and 1, 3. Go ahead and graph. Go to your origin. Go to the left one, down 1. That's -1, -1. For 0, 1, you go nowhere for x, then up 1. And then for 1, 3, you go to the right one, up 3. Connect the dots, and notice you have your line. And I have them going in this direction to infinity and in this direction to infinity. And that's why it didn't matter what values you chose for x. But let's say if we chose 10 for x, when you plug it in, it will give you a value that will meet this direction or this line in this direction at some point. Same thing if you chose -20, it will give you a point that's way down here that will connect with the line in this direction at some point. So this line goes into infinity in this direction and goes into infinity in this direction. And each point on this line represents an order pair that is the solution for this equation. All right, let's do another one. We have y equal to -1/3 x plus 5. So you can choose any values that you want, but whenever you have a fraction, it's always best to choose multiples of the denominator. In other words, something that the denominator can divide into even. Our denominator is 3 here, so I chose -3, 0, and 3. So you want to choose values that will eliminate the fact that you have a fraction. So if I were to plug in -3 for x, -3 times 1/3 would be +3/3, which will reduce into 1. Then 1 plus 5 is 6. Going in 0, -1/3 times 0 is 0, so 0 plus 5 is 5. Then times 1/3 times 3. If you plug in 3, will give you -3/3 plus 5, which would be -1 plus 5, and that's 4. So when x is -3, y is 6. When x is 0, y is 5. When x is 3, y is 4. Plot those 3 points individually, and then connect your dots, and you have a line. And that line represents your equation. All right, that was the first method. The second method is to graph using your intercepts. So your x-intercepts, you will graph intercepts across the x-axis. And for the characteristics of your x-intercepts, y is always 0. That's the characteristic of all x-intercepts, that y is always 0. Then for your y-intercepts is where the graph intercepts across the y-axis. And the characteristic of all your y-intercepts is that x is always equal to 0. So if you have the equation 2x plus 3y equal to 12 and you want to graph using your intercepts, this method is always useful when your coefficients of x and y can divide into your constants. In other words, 2 and 3 can divide into 12 evenly. So if you have that, then that would be one of the best scenarios to use your intercept method. So for your x-intercept, it doesn't matter which one you decide to find first. If I want to find my x-intercept first, I let y be equal to 0, plug in 0 for y. That 3 times 0 will cancel, leave me with just 2x equal to 12. Divide by 2, x is equal to 6. So that ordered pair would be 6, 0. Then find your y-intercept. You let x be equal to 0. Plug in 0 for x. 2 times 0 is 0. That leaves you with 3y equal to 12. Divide by 3. Y is equal to 4. So that ordered pair would be 0, 4. Don't forget, x comes first, then y. So x is 0, y is 4. Graph those 2 points, and that will be your line. Do that again. If we have 5x minus 4y equal to 20, Finding your x-intercept, let y be equal to 0. Plugging in 0 for y, that cancels out the 4, leaving with just 5y equal to 20. Divide by 5, x is equal to 4, so you have the order pair of 4, 0. Then to find your y-intercept, let x be equal to 0. Plug in 0 for x. That cancels out the 5, leaving with negative 4, y equal to 20, so don't forget that negative. Divide both sides by negative 4. Y is equal to negative 5, so that's 0, negative 5 is an order pair. And graph those 2 points, and you will have your line. Horizontal lines. Notice that in our equations previous to this one, we always had an x and y involved. Whenever you have a horizontal line that's going to be created, all you have is the y that is in your equation, no x. So here we have y equal to 3. What this says is that y is always equal to 3, and x can be anything. So no calculation, just observation. X can be anything, but y is always going to be 3. So if that's the case, when you go to plot these points, negative 1, 3, 0, 3, and 1, 3, you'll get a horizontal line at 3. Same thing would occur if you have y equal to 5. That means y is going to be 5 no matter what. X can be anything, and you will have a horizontal line at 5. Vertical lines are created when all you have is x involved in your equation. Here we have x is equal to negative 2, so that means x is always negative 2, and y can be anything, and that will give you a negative 2, a vertical line at negative 2. All right. Slopes. So the final method is your slopes, graphing using your slopes. So your slope just represents the slope of your line, or the incline of the line, or the steepness of your line, just like the slope of a mountain or the slope of a ramp. And this gives us a numerical value that represents that steepness. So we have y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. It doesn't matter which one you use, as long as you stay consistent. Y2, if y2 is used first on top, that means x2 is used first on bottom. Or y1 used first on top, that means x1 is used first on the bottom. And it also represents rise over run, which we will get to that relationship shortly. Also notice that M is what's going to represent slope for us, not S. It's going to be M. And that x1, y1, x2, y2 comes from your point 1 and point 2. They represent any point on your line. So point 1 will be considered x1, y1. Point 2 will be considered x2, y2. Once again, they are any 2 points on your line. So the essence is to find the slope of a line that goes through the points negative 1, 3, and negative 4, negative 2. What I always suggest is go ahead and label which one is point 1 and which one is point 2, then substitute accordingly. So we'll call point 1 negative 1, 3, point 2 negative 4, negative 2. Then that means that y2 is going to be negative 2, and y1 will be 3. And then x2 will be negative 4, and x1 will be negative 1. Make sure you don't lose a negative in your substitution. So negative 2 minus 3 is negative 5. On bottom, negative 4 minus negative 1. Don't forget that negative 2 negative turns positive, so there's negative 4 plus 1, which would be negative 3. And so negative 5 over negative 3 reduces down to 5/3. In the next one, I just wanted to show you how both of them will end up giving you the same thing as long as you stay consistent in your substitution. So I have y1 first and then x1 first on bottom. So let's substitute in that way. That would be 3 minus negative 2. And then on bottom, negative 1 minus negative 4. Once you make sure you don't lose your negatives. So that'll be 3 plus 2 on top, negative 1 plus 4 on bottom, which will give you, once again, 5/3 as your slope. All right, we can do that one more time. Negative 5 and 2 as one point, positive 1 and positive 3 as your other point. That's called point 1, negative 5, 2, and point 2, 1, 3. So if I'm doing the relationship with y2 minus y1 over x2 minus x1, y2 is 3, y1 is 2, so that'd be 3 minus 2 on top. X2 is 1, and then x1 is negative 5. So that's y1 minus negative 5 on bottom. And so 3 minus 2 is 1. 1 minus negative 5 is 6. And that would be your slope, 1 over 6. All right, so graphing using your slopes. We said the last part of that relationship with your slope was rise over run. Your rise is going to be up or down, while your run on bottom will represent right or left. Now you have positive moves and negative moves. So your positive moves are up and right. Your negative moves are down and left. So that would dictate whether you go up or down versus left or right and vice versa. So when I look at 5 over 3, that's a positive 5 over a positive 3. So that means I will go up 5 and right 3. Those are my positive moves, up and right. So I have two positive numbers, up 5, right 3. Another example, let's say if I had negative 7 over 4. So that negative 7, that would be down 7. And then that's a positive 4. That negative is not given to the top and bottom. You have to choose which one you want to give it to. If I decide to give it to the top, that means the bottom is positive. So it's negative 7 over a positive 4. So that's down 7. And then your positive move on bottom is right. So that'll be right 4. If I decide to put the negative down bottom, then that means I have a positive 7 over a negative 4. So that's up 7 and then left 4. Either way, you would still get the same line. So before we use our slopes to graph, we also need to recognize that there's a slope-intercept form, y equal to mx plus b. And we want to make sure our equation is in this form. That's whenever your equation is solved for y and simplified as much as possible, the number that's in front of x is your slope. And then the other number is your y-intercept. So once again, the number that's in front of x is your slope, and the other number is your y-intercept. So if I look at the equation y equal to 3x plus 5, my slope is 3, and my y-intercept is 5. If I have the equation y equal to negative 1/2 x plus 4, my slope is negative 1/2, and my y-intercept is 4. All right, so let's use that information to graph. If I have y equal to negative 1/2 x plus 4, that means my slope is negative 1/2. That's negative 1 over positive 2, so I will go down 1, right 2. My y-intercept is 4. And don't forget, if it is your y-intercept, the characteristic of all y-intercepts is that x is equal to 0. So the coordinate of a y-intercept that is 4 would be 0, 4. So your steps to using your slopes to graph, you always graph your y-intercept first. So I'm going to graph the 0, 4 first. So it's going to be on the y-axis because remember it's your y-intercept. So you go nowhere for x and go up 4. That's my y-intercept. And then I would generate another point from the y-intercept. I don't go back to my origin. I go to the y-intercept and I go down 1 and right 2. And that will be my line. And I can continue to generate more points on that line by going down 1, right 2, down 1, right 2, down 1, right 2. And it will continually generate points that are on my line. So once again, you graph the y-intercept first, then from the y-intercept, graph another point by using your slope. So let's look at this last one, 3x minus 5, y equal to 3x minus 5. Your slope is 3. Your y-intercept is negative 5. So if your slope is 3 as a fraction, that will be 3 over 1. It's positive 3 over positive 1, so that'll be up 3, right 1. Then my y-intercept is 0, negative 5. So I go graph my y-intercept first. So I go down to the 5. And then to generate another point, I go up 3 and right 1. And that will be my line. Let me know if you have any questions.